I was making sure I checked the title card that time round. I've made my first mistake of number 7 says number 2 at the start. And I think I'm too lazy to go back and fix it. I never bother to edit these. Just record them out on OBS, but yeah, sorry, rambling. 2 sum digits, which I then couldn't decide what to call them, but I was happy enough with what I named them on that first screen. Digits along each line sum to the same number, but you can't have the same combination of digits anywhere. And clues outside the grid give the sum of all digits that contain a line segment. It's like those sum to 21, those to 16, etc. So that's question mark 9. You haven't really given us any that what am I trying to say? So oh no, that's counted twice. So I was thinking about if you could somehow say, I know what the sum of that is, but that gets ignored, sadly. What do we know? The minimum this sum can be is going to be, can't be less than 10, surely. How many ways are there to make 10? 4, 5, 2, 3, 5. There's only 4, 5, 6, 7. Needs 7 different things, which make 11 7 ways? No, surely not. No, I was doing it in 2s. Yeah, in fact, this is going to be very restricted, isn't it? Because things like 20, you can only make like that or that or that. I'm not about. There's a few more, but that's all of them, isn't it? Yeah. Right, I think I do need to think about this properly. 1, 2, 8, 1, 3, 7, 1, 4, 6. There's probably a straightforward way I could do this, but going with this. So there's only 5 ways, and I said I need at least 1, 2, 3, 4, 5, 6, 7. At least 7 different ways. So 11 doesn't work. Does 12 work? 1, 2, 9, 1, 3, 8, 4, 7, 1, 5, 6. 2, 3, 7, 2, 4, 6, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So there are 7 ways to make 12. And then these guys could just do whatever they want, because they could be like a pair of 1s and a pair of 2s or whatnot. So 12 is okay. And what's the... Can I just say the other end of that by doing 30 minus 12, I want to say? Because you're basically just saying, oh, I'll flip 1, 2 to become 9, 8, 1. Yeah. So the sum is between 12 and 18. And if... I should have been looking at this, shouldn't I? If the sum was 12... and that's not summing to enough, because that's going to sum to at least 20. Yeah, it's got to be at least 13 from this guy. If it was 18, that would have to be a 3. That would sum to 21. That would have to be a 4. And then that doesn't work, so it can't be 18. If it was 17, that would be a 4. That would also be a 4. So 17 doesn't work. If it's 16, that's a 5. Hang on, isn't this just always 4? 16. 5. Yeah, that's just straight up always 4, isn't it? Because 25's 4 more than 21. Not using my brain properly today. So 16, 15, no, sorry, 16, 15, 14, 13. And so if that's 16, that will be 5, 4, 7. 15 would be 6, 4, 5. 14 would be 7, 4, 3. 13 would be 8, 4, 1. Seems similar to the one with modulo 3 sums and the sums pointing to these guys as well. So this would be... No, so 1 doesn't work, does it? So it can't be... What did 1 pair with? 1 paired with 8, I want to say. If that's 13, yeah. So 13 doesn't work. So if you're 14, you're 7, 3, 7. No, that's got some 16. 3 forward, but 9. 6 and 5. 4, 5, 7. And 3, 4. No, sorry, 7, 4, 5. Yeah. Cool. Something to 14 though, something to 17. It's a lot of freedom along there, isn't there, to be honest? I don't think the 24 particularly helps either. Interestingly. See some to 12, yeah. See some to 9. Five and 20. That 20 doesn't use a 4. I was about to say that can't be 5, 6, 7, but 5, 6, 7. Some to 18. So can we... Is it worth getting all of those options? Ways of making 14, 15 and 16. I feel like it could do. I used to have a cheat sheet bookmarked of all the killer stuff. I think I deleted that. I'd probably find it easily though. Yeah, because you don't really know much about how that line works, do you? Every line contains a different combination. Is it worth thinking about how to get there? 1, 6, 7, 2, 2, 3, 9, 2, 4, 8, 2, 5, 7, 3, 4, 7, 3, 5, 6. 1, 2, 3, 4, 5, 6, 7. So there'll be 8 ways to get there to make 14. Of them would need a 9. It's probably similar with 16, isn't it? Yeah, because isn't it the same thing that you're just flipping the things that sum to 10 to get all the ways to make 16? But I think there's one more way to make... sorry, let's do the ones first. Just thinking about the ways to make... Go on, use your words. No, because 4, 5, 6... Yeah, so there's always 8 ways to make 14, 15 or 16. Implying that at least one of these has shared digits. I reckon it's maybe 15 and they're all 5s. It's going to be my prediction. Feels kind of likely. this guy. It'd be nice. Surely that comes in near the end, doesn't it? Like it must do. Hmm. Yeah, here's a thought. These two are quite small. What's the biggest they can sum to? Is 13. But then, yeah, because that could be a 1. Because I was thinking, I wonder if that has to be quite big. But I don't think it does. Right, where's the break-in? I wonder. I was pleased to get that relatively narrowed down. Going back to looking at this. Trying to metagame it, thinking about the 8 disambiguating things, but the sums will disambiguate things as well. I was just curious about sort of frequency of digits in these setups and how, what am I trying to say? How you can only get a certain number of certain digits, but the lines are actually quite lenient in that case. You can hide plenty of digits everywhere that aren't forced on lines. Like this digit is forced on 2 lines, but I don't think that means much. And the digit, in all of these cases, I'm pretty sure, there are only, you can have at most 3 of 1 digit. Oh no, you can have 4 5s. Maybe that is something interesting. And let's just check this. 3 1s, 3 2s, 3 3s, 3 4s, 3 5s, 2 6s, 3 7s, 2 8s, 2 9s, 2 1s, 3 2s, only 2 3s. Interesting. 3 4s. The rude 5s working multiple ways. 6s, 7s, 8s, 9s. So now I've now got to remember why I was actually considering that. And I think the thinking was if I can prove that a digit has to appear 4 times on lines, then on these straight lines, then it'd have to be a 5 that's doing that. And you'd have to be summing to 15, which would mean 6 and 5, etc. So that is looking more and more likely, I'd say. And also having something, an unknown number sum to 15 is just a very apt thing for Sudoku, really, isn't it? And at the moment, I'm struggling to tell if the break-in is something meta like this. Or is there just more obvious stuff I can do? Like, how's that ever a 9? That's when that's a 3 and that's a 7. And this sums to 14, so they would have to sum to 5. Okay, that is something interesting, isn't it? if the cell is 9, then I know the sum is 14. And these two would have to be different. And these are our sums to 14. And the reason I think that's potentially interesting is that's then 8 different ways of making 14. Isn't that the same as 16? That maybe. No, I don't think so. If that's 16, that's 5. That's 7. That would be 5. Wouldn't it? Yeah. Yeah, so you could be a pair of 5s and a 6. So only in the case of 14 is this then acting funny. Is something vaguely interesting there not allowed to sum to 9? But we know that anyway, they either sum to 5 to 8 or to 11. So I'm a little stumped at the moment. What am I not seeing? I don't think it can be the fact that they sum to 10, 11 or 12. That's not that useful. And I don't think the question mark 9... Tell a lie. Maybe the question mark 9 helps more than I think. So let's say these sum to 14. Then I know that's the case of 7, 3, 9. I really wish, by the way, that you can copy and paste groups of cells. So I kind of want to keep this, but then shift it somewhere else. What I'll do is I'll just duplicate that. Then I can always go back to it to refer. So in the case that that's 14, with a 9 here and a 1, 2, 3, 4. I was thinking about how... Yeah, I think I can disprove 14. Because I know that these have to repeat. And I know that these either sum to 5 or 15. They'd have to sum to 5, so those two cells would be the same. But that implies that these two cells have to be the same. So that could be a pair of 5s. 4. Yeah. And I know that those sum to 9. So that just... Oh, it works with 5s and 4s. Maybe 14 is the way. See anything wrong with that? Having to sum to 14? Probably not. That you've used 1, 5, 1, 4, 9. That should be okay, really, shouldn't it? This one takes the other 4. Is that problematic? There's only 3 ways to do that. Oh, that would be the 3, 7. So that would have to be 4, 5, 6. Giving you a 5 here. That could be 2, 3, 9 or whatever, couldn't it? Ha. That sums to 14. I know that sums to 28. Sum to at least 12. You know what I haven't done? Is have a look at like a massive set sort of style thing. So if I just mark everything that's counted, do everything that's counted twice. And then maybe take off 1, 2, 3, 4, 5, 6. Got 6 of the sum. Oops. So I know 6 of the sum plus these digits equals the total of that, but with the question mark 9, that still leaves some ambiguity, doesn't it? Sure if my brain's going to be up for this one. Normal Sudoku. Digits along each line sum to the same number. Every line a different combination. Who's outside the grid give the sum of all the digits which contain a line segment in that row or column. Just double checking I've read them properly, because last puzzle I went through something and then completely misread a very important. Well, not very. I don't think it was as important as I thought in the end. I thought getting a digit off the bat would help us out as well. And you know that 2 lines can't share 2 digits. So, for example, if that 4 went over here, it means that that has to go on that line. Yeah, is that interesting at all? If 4's over here, it's annoying that I think that those 2 digits can be the same. They could be a pair of 7s with a 1. They could be a pair of 5s with a 6. Why are both of those options viable? And I managed to get that to work, didn't I, with 4. 5, 5, 4. 1. What am I missing? How long has it been? 20 minutes. Haven't seen anything. And I mean, if they are all the same, they all have to be 5s. But that could be then a pair of 8s and a pair of 7s and a 1 or something. If these 3 are all the same, they're all a 5. This cell's also 5. This line's got a 5. There's so many ways you can chuck a 5 on a line. It doesn't matter at all, this line would have a 5. Yeah, there's just plenty of ways that works. Ha. I give it 5-10 minutes. And gonna have to have a break and come back to this one. I mean, if this was that big, you know that in the case that's 14, that has to sum to 5. In the case that that's 15, is that allowed to sum to 14? This would already be summing to 21, 30. No. So, in the case that your sum is 15, if that tried to sum to 14, that would sum to 21, that sums to 30, that breaks. So this would sum to 4, 11, 20, and that would be a 10. Wow, 15 doesn't work. How the hell does 15 not work? 15 doesn't work. That's a curveball and a half. All bets are off now. God, I'm actually really surprised about that. And now let's try and think about 16 more carefully. Because if this was a 5 and then a 1, 2, say, that would be a 9, and then that breaks there. So in the case that that's 16, I know that this sums to 13, 18, 27. Oh my god, it needs another 5. That is crazy. Right. So we are definitely 14. Our special sum. I should have been checking that way more regularly. I just didn't trust this question mark 9 at all. So apologies for that. That's 7, that's 3. And it probably is useful to make note of all of my ways to make 14, isn't it? Trying to do like 9 by 9. Except that's not even what I wanted to do. Maybe I'll just bring it up on Notepad. That's probably easiest, isn't it? Notepad notes. Nice. Let's just chuck that there. Hopefully I'll be able to write that in. So, the ways to make 14. 149. Actually, let's do it. 149. 158. 167. I had these written down already at some point, didn't I? 239, 248, 257, 347, 356. Cool. Excellent. Look at that. And I've used 347. I can just chuck an X there, maybe. Yeah, look at that. Very good. I know that this sums to 5, and I in fact worked out that this had to repeat. Oh, what if those two repeated? No, because those two are the same, aren't they? So I know that these two have to repeat, so they've got to be 5 or 6. The problem with them being 6 is that's then 2, and that doesn't work, so that's got to be 5, 4, 4, 1. Puts 4s here, puts 4s here, so that's either 2, 4, 8 or 1, 5, 9. Are those going to be a problem? Probably not. And we've used 1, 4, 9. Oh, we've used 1, 4, 9. So that is 2, 4, 8. That's that one done. So we can't have another 4 on any lines. What else have I done? I've done that. Whoops. Basically done that, basically done that, done that, done that. These sum to 10. 4, 6, 9, 7, 3, 4, 6. If that tried to be 9, that would be 9, 2, 3. That's okay. I was about to say these can't have a 4 on them because I know that sums to 10. Well done, Joanne. Very smart. This 14 is going to make these sort of clues very exceedingly average. was 2s, 1s, etc. And I know I've got to use one of these every single time. So, for example, this couldn't be 167257. One of these needs a 3, so one of them is either 239 or 356. Those sum to 14. That's 28. Need another 17. So 4 and something to 13. So yeah, that's kind of big. Whoops. Like that. Takes at least one of 7 or 8. So if that was a 7, 8, 2, 3 pair. Does that mean anything? Probably not. I know that 9s go on these lines, don't they? Look at that. So one of these is 9, 2, 3. Which is, I can't really cross off. I might put like a little tilde or something. So 239 I know is in box 1, box 3. One of them's 239 and the other one, therefore, can't be that. So it's either 158 or 167. And it's got to be this one. So this one is 239. There you go. Progress. And this is either 167 or 158. Lovely. That all looks like that works happily. 1s are down there, 2s are up here. 5s go across there. Awesome. Have we used all our 1s with 3s? No, there's 3, 5, 6, so we've got to place somewhere. The 1s with 8s on them. Got to be a 158 somewhere, but still got some options. Oh, I know that there's sums to 10, don't I? So that's not 3. There's still a couple of ways that works, annoyingly. And I have definitely used all this, haven't I? Yeah. Surely. I think so. So I know that that sums to 14. And that sums to 14. That sums 17. Sorry, I know that pink sums to 14 adds 17, 31. I know that blue sums to 14 times 3, which is 42. Cancel those. Do blue minus pink gives you 11. So the sum of those minus that is 11. None of those can have a 9. So they can't be that big. So I was wondering if that's 8. Then this has got to sum to 19 without using a 9. How do you do that? Have we used all our... We've used all our 4s as well, haven't we? So I'm not allowed a 4 anywhere up here. That's what I was wondering about. So how do I make 19 without using 9 or 4? 3 doesn't work. So you'd have to be, that would have to be a 5, 6, 8 triple. Anything wrong with that? If that's 8, that's a 5, 6, 8. There's a virtual 8 somewhere there. Unhelpful. Probably, anyway. So if that's 8, this is therefore 5, 6, and 8. And one of these would be an 815. Well, that would have to be 8 and 5, 6, wouldn't it, of course? 851. Is that then all low ones with 5s? No. Got a 3, 5, 6 to place. This would become an 8, 6, 7, a 1, 6. Right. Let's try and use our heads a little more. Just trying to remember why I got rid of that, but I remember now. So I've used 158 as well. That one is down for the count. So we can't have any more 8s. So this can't be 8. That is an 8. Lovely. 4, 7, 5, 8, 1. Let's get rid of that nonsense for now. Although there is obviously still something interesting going on there. In terms of what? So I know that, I'll write this down here as well. I know that pink minus blue is 11. I think because it was 42 minus 31. Yeah. Pink minus blue is 11. And what have we got left? We got a 167, a 257, and a 356. And that's just those lines, isn't it? So in fact, what I'll do, I'll just get rid of that for now. A 167, a 257, and a 356. So a 5's interesting. I'm just going to write that string out. 1, 2, 3, 5, 5, 6, 6, 7, 7. I have 2 5s, 2 6s, 2 7s. One of 1, 2, and 3. What does it mean? That's 5. 1, 2, 3, 4, 5, 7. Yeah, 6, 8 pair. 5, 7, 5, 7. Oh, we'd have for 1, 2, 9. It's not 2, that's not 1. 2, 4, 8, 5, 7. Not a 9. Knew that was Sudoku to be done. 2, 7, 8. And of course this sums to 14, doesn't it? And this sums to shift that over on that side because I find it easier. It's 11 add blue. Ah, there we go. I want to move that. 2, 3. That's just going to be something to 10. That's fine. 9s? Not really. 4s? Also not really. If that sells 4. Yeah, if that sells 4, it breaks. Get 4s here, 4s here, 4s there. But otherwise, you're fine, aren't you? Yeah. So is there... Yeah, there's that cell can't be 4, for example. I thought there was something with an 8 in it. I was looking at that. And there's not anything with a 1 and 5 either, is there? Of course there can't be, because it would have to be 1, 5, and 8. What a fool. Oh, jeez, sorry. It's summing to 17. Is there anything you can say about odds and evens? Yeah, maybe. If that was taking 2, 4, and 6, it would need a 5. If it doesn't take 2 or 6, they're all odd. Can it be 1, 3, 7? 1, 3, 7 would need another 6. No. So that definitely always has a 5 in it. Possibly not all that useful. Weird. Very weird. So one of these is a 167 triple. And it's not that one, is it, Joan? That's got to be 3, 5, 6. More things of me just not looking at what's going on at all. So one of these is a 167, looking at a 4. The other one's a 2, 5, 7. So we've definitely got 7s here, meaning we can't have 5s. That's a 5. Because you need another 7 here. That's got to be 6 and 1. Nice. Right. Back on it again, I think. 7s, 8s, 2s, 7s. Lovely. 1, 2, 4, 5, 8. 6, 8. There. 1, 5, 6. 1, 5, 6 looks good. Nice. No, that definitely does have a 7. So 7s are up here. 2, 5, 8. 9s are there. Good. Right. That is just a 2, 5, 6, 7. So that's what? 1, 3, 4, 9. Eights, 8s, 5s. Yeah, 5s are here, of course. I think that can still be whatever it wants. This is now crossed off. So there's some relationship here that I'm going to have to think about at some point, aren't I? And whichever one isn't the 1, 6, 7 is going to be a 2, 5, 7. So if that's 2, 5, 7, that's 1. So that can't be 2, 5, 7. Good. Got there eventually. Nope. Yes, 1, 6, 7. 4, 6. Right, much better. Hide that though, I might need to come back to it in a moment. 2, 3, 9. What's this? 4 and 9. 4's got up here. Yeah, 4 there. 4, 2, 4. Oops. 2, 5, but it's 9, 1, 8. So that's now done. 3's here with an 8. 2, 3, 6. That's still not sorted. 1, 2, 8. Ha! What's going on here? Ha! I know they sum to 13. So if that was 5 and 3, that wouldn't work. So that's got to be 2, 5 like that. That's 7. That's 6. And 6 and 1. 1 and 9. 7, 9, 6. So there's a 9. 9, 7, 3. 6, 9. 1, 2, 7, 8. 2s and 8s and 8s and 7s. There's a 1, 8 and a 2, 7. 1, 6. 6 there. 7, 2, 3, 2. 3, 2. Lovely job. Sorry about the start. I just didn't bother sort of doing anything, did I, for 20 minutes? Which wasn't very clever. When I saw it, it then made a lot of sense. And I was vaguely in the right area, at least. But yeah, thank you very much for the puzzle. Thanks for watching. Hope you enjoyed. Chat to you all later.